acid rain is a very dilute solution of nitric and sulfuric acids with a pH of around 4. Now we will learn about ways in which we can either make this acid rain less acidic or at the very least reduce its negative effects on our environment. Can you remember where the nitrogen came from in the nitric acid and the sulfur in the sulfuric acid? Pause and think. Well, the nitrogen came from the combination of atmospheric nitrogen and oxygen in the cylinders of motor vehicles, and the sulfur when fossil fuels containing sulfur are burned, particularly in our power stations. Let's look at power stations in Europe. For many years, these stations have been using tall chimneys to disperse the sulfur dioxide far away, thinking that dilution was the solution to pollution. However, the acid did not get diluted, but instead was carried in the wind to Scandinavia, where it fell into Swedish lakes. Originally, people tried to neutralize the acidity by adding limestone to the lakes. This was partly successful. For example, salmon returned to some polluted rivers in Wales after the acidified lakes from which the rivers flowed were treated with lime over a number of years. A much better method is to trap the acid before it reaches the atmosphere in a process called scrubbing. The kind of scrubber we need in this case is an alkali to react with the sulfur dioxide. So either seawater, which contains a little bit of sodium carbonate, or lime, calcium oxide, is used. Can you think what reaction will occur with calcium oxide, a basic oxide, and sulfur dioxide, an acidic oxide? Calcium oxide plus sulfur dioxide makes calcium sulfite, that's CaSO3. The sulfite can be reacted with oxygen to make gypsum, calcium sulfate, CaSO4, which is the main ingredient of wall plaster. These scrubbers have greatly reduced our sulfur emissions and given many countries much cleaner air, but it does reduce the efficiency of the power station, maybe by as much as 10%, thus increasing the cost of the electricity. In oil refineries, sulfur is removed from crude oil by reacting it with hydrogen. This reaction, known in industry as hydrodesulfurization, takes place at high temperature with a metal catalyst to produce hydrogen sulfide, that bad egg smell and a very poisonous gas. When this purified oil is refined into various fuels, it is virtually free of sulfur. What about reducing the amount of nitric acid in rain? This time we need to put catalytic converters in the exhaust pipe of all our motor vehicles. Essentially, they convert the oxides of nitrogen back into oxygen and nitrogen. It is a pity we have to do this because we use huge amounts of fossil fuel energy getting nitrogen to react with hydrogen to produce nitrogen-rich fertilizers. With a little collector in all the exhaust pipes, we could deposit a little pile of fertilizer every time we fill the fuel tank. There's an idea for one of you young entrepreneurs. So to summarize, the best way to reduce the effects of acid rain is to prevent the oxides of sulfur and nitrogen from escaping into the atmosphere in the first place. This is done by scrubbing the exhaust fumes from power stations using lime or seawater to remove the sulfur dioxide, and by fitting catalytic converters to motor vehicle exhausts to decompose the oxides of nitrogen.